All right, for this lecture recording, we are going to use the critical path method to create an AON, or activity on node network diagram. We are going to use the example from the book of Milwaukee Paper. I highly recommend that for this lecture that you print out a copy of the blank AON network diagram that I've provided on Canvas so that you can follow along with me while I go through this video. I'm going to move fast going through the AON network diagram, and so this is one of those lectures where you really need to pay attention, watch the screen, and then write down things as we go along through them. If you have any questions, you can always re-watch the video, and hopefully as you see it a time or two, it'll kick in a little bit more and it'll make a little bit more sense. But hopefully the pace that I go is acceptable for all, not too fast for some and not too slow for others. But we're going to go through and create an AON network diagram together for Milwaukee Paper. All right, so Milwaukee Paper. Milwaukee Paper Manufacturing had long delayed the expense of installing its advanced computerized air pollution control equipment in its facility. The board of directors adopted a new proactive policy on sustainability, and they'd like the plant manager to complete the installation of this new equipment before Earth Day. Earth Day is 16 weeks away. Milwaukee Paper's identified 8 activities that need to be completed in order for the project to be done. See the following tables for activity precedence relationships. I'm going to give you all the precedence relationships, all the time and estimates that are needed, and then we're going to do an AON network diagram together. So we're going to do that diagram. We're going to compute the early start and early finish times, as well as the latest start and latest finish times. We will calculate out the slack for every activity, and then finally we will calculate the critical path for the Milwaukee Paper project. Okay, so for Milwaukee Paper, this is given to you, and we have every activity, the description for that activity, and then we have the immediate predecessors. So remember, when we fill out the AON network diagram, we don't want to write in there, build internal components, or modify roof and floor. We're going to assign an activity number, or letter, or code to every task, and in this case we've chosen A, B, C, D, E, F, G, and H. So the 8 activities have all been assigned a number, or a letter. The immediate predecessors. So we have already determined what those immediate predecessors are. Now, what you're going to have to do, because this won't be given to you many times, whether you're doing homework, quizzes, or even your exams, you're going to have to be able to draw out the AON network diagram. And I can give you just what you see on the screen, because this is enough to create the AON network diagram by itself. So I'm not going to stop and pause and give everyone time to draw out an activity on node diagram right now, but I would highly recommend that you practice and just use this one as your example. There is no activity node that says start. So you can see that there's activity A and there's activity B. If there's ever 2 starting points, like there is in this example, I would write start. I would make it its own activity. I like to have 1 start and 1 finish. So even if there are multiple starts and multiple finishes, you can do your own start and your own finish. And that will be easier to understand, what my first activities are and what my final activity is and how long the project's going to take. I highly recommend you always make a 1 solo finish node. So these are all the immediate predecessors for every step. You can see that, let's just jump to D, activity D, pour concrete and install the frame. Activity D cannot be done until the immediate predecessors of A and B have been completed. Okay, so all of these activities, you can see the ones that precede each other. C cannot be done until A is done. E cannot be completed until C is done. So one other little trick, besides putting a start and a finish, that I like to do is I actually go backwards through these. I have found that it's easier to start with H and then go to F and then go to G. So start with my H and then go to F and then go to G. And the reason I do that is I'm less likely to get my arrows crossed as I work backwards. Now, odds are pretty good when you do this the first time, you're still going to get a cross between some of your letters, and that's okay. You'll still get the right answer, but I would recommend that you redraw your AON network diagram so that you don't have any of your arrows crossed over each other. So this is what your AON network diagram looks like for Milwaukee Paper after you've gone step by step determining the immediate predecessors. Okay, now here are the time estimates. And again, these are all given to you. So activity A is going to take 2 weeks. Activity B is going to take 3 weeks. Activity C is going to take 2 weeks. And it goes down the list. So you've got your 8 activities and your time estimates for every single one. And because this is the CPM method, these are fixed times. They do not vary. So real quick for this example, one thing I want to point out right now is you can see you've got every activity time. On the far right, you've got every activity time. You've got your 8 activities on the left. Do not just add up all of the activity times, and that's your project completion time. So if you add up all of these times on the far right, you're going to get a total of 25 weeks. But this project does not take 25 weeks to complete because you can do some projects in parallel at the same time together. So this project does not take 25 weeks, even though if you add up every single activity, it does, because you're doing multiple activities at the same time. Okay, next, now we're going to put everything into our Sudoku squares. So you can see you have drawn out your AON network diagram. You've got your Sudoku squares. I have already populated the activity times. So A was 2 weeks, C was 2 weeks, F was 3 weeks. So you can populate in your activity times. And let's do an example together. All right, so this was provided to you in the last lecture. These are your CPM steps and your rules. Step 1 for our forward pass. Your first early start equals 0. It always equals 0. Your first early start always equals 0. Then rule number 1, your early finish for an activity equals your early start plus the time. Then rule number 2, the early start time for an activity equals the largest early finish time of all the immediate predecessors. Okay, so let's do a forward pass together. So high level for forward pass, we're adding things up. We're using the largest early F number. We look at all the immediate predecessors and we're going forward through this network diagram together. All right, so let's start with the start. So our first rule is that our first ES equals 0. So you can see at the bottom left of this sheet, I've got a little cheat sheet for you. Your ES is always the top left. Your LS is always the bottom left. Your EF is the top right. And your LF is the bottom right. So going forward, doing our forward pass, we're going to calculate our early starts and our early finishes. So for our start, we're going to take 0 plus 0 equals 0. That one's pretty self-explanatory. Now let's go to A. So looking at the largest EF, your immediate predecessor. Well, your immediate predecessor is the start. So you're going to take 0. Now for A, you're going to calculate your early finish. Your early finish is the top right. You are going to take your early start of 0 plus your time of 2. And that will give you your early finish. So 0 plus 2 equals 2. Now let's go to B. Your early start equals 0. You used the same early finish for both A and B. So for B, your early start is 0. Your activity time is 3. So to calculate your early finish, you are going to take 0 plus 3 equals 3. Now let's go to D. Okay, we're not going to go to C, we're going to go to D. And we're going to go to D because D has 2 immediate predecessors. This is the first time you've got to make a decision. So D has 2 immediate predecessors. For our rules, you're going to pick for your early start the largest of the immediate predecessors. So for D, B is a predecessor and A is a predecessor. So your largest early finish, you have to pick between A of 2 weeks and B of 3 weeks, and 3 is larger than 2. So you will take 3 weeks as your early start for D. Okay, that is the first time you have to make a decision because you've got 2 immediate predecessors. 3 is larger than 2, so you take the 3 as your early start time. Take a step back and think about why that is. If activity D has activity A and B go into it, if activity A is going to take you 2 weeks to complete, and activity B is going to take you 3 weeks to complete, you're going to do activity A, it's going to take you 2 weeks, and then it's going to sit there for 1 week because you can't start activity D until activity A and B, the predecessors, have been completed. Activity D can't start until activity B is done, and activity B takes 3 weeks. So the earliest time you can start D is the 3rd week because activity B was your longest lead time item. It had the longest duration of 3 weeks. That's why your early start time has to be the largest EF before an activity can be started. So your early start time for D is 3. So 3 plus 4 equals 7. Okay, now let's go to C. For activity C, there's only one immediate predecessor, and that's A. So the early start is 2. 2 plus the activity time of 2 gives you 4. All right, now let's go to E. E only has one immediate predecessor, and that's C. The early finish for C is 4 weeks, so our early start for E is also 4. Activity E has a 4-week lead time, so 4 plus 4 equals 8. Now let's go to F. Activity F only has one immediate predecessor, and that early finish of activity C is the 4th week. So activity F, your early start is week 4. It has a 3-week duration, so activity F will have an early finish time of 7 weeks. Now let's go down to G, down at the bottom of the screen. G has 2 immediate predecessors, so once again you've got to make a decision. Your immediate predecessors are activity E and activity D. Between E and D, the largest early finish time is 8 weeks. So for G, you will also pick 8 as your early start time. So for activity G, your early start is 8 weeks. Then you add your 5-week duration, and that gives you 13 weeks as your early finish. Now for activity F, you're going to also have a decision between activities F and activity G to determine what is our early start and early finish for activity H. So activity H, your early start is 13 weeks. It has a 2-week duration, so you will be done with your early finish at 15 weeks. Okay, but we're not done. Now we have to do our backward pass. And our rules for our backward pass is essentially the opposite of the forward pass. We're going to subtract. We're going to use the smallest number. We're going to look at the immediate successors. And we're going to go backwards through that AON network diagram. Our rules for the backward pass is that our first latest finish time equals the last early finish. Okay? So our first LF equals the last EF. They will always be the same. Our LS, our latest start, equals our latest finish minus time. And then rule number 4 is the latest finish time for an activity equals the smallest latest start time for all of the immediate successors. So now let's do the backward pass. Now we're going to start with activity H. Okay, we start with activity H. And our first rule is that the first LF equals our last LF. So simply put, for H, our first LF is 15. So 15 is our first LF. Now, to calculate the latest start time for activity H, we're simply going to take 15 minus 2, and that will give us 13 for activity H. Now let's go to activity F. So activity F only has one immediate successor, and that is H. So we will be picking 13 as our latest finish for activity F. Now we're going to take, for activity F, to calculate the latest start, we're going to take 13 weeks minus the 3-week duration, and that gives us 10 weeks as the latest start time for activity F. Now let's go to G. For G, we look at the immediate successor, which is H, and that has a 13-week latest finish. So our last, our LS equals our latest finish minus time. So for G, you're going to take 13 weeks minus your 5-week duration, and that gives you 8 weeks for G. Now let's go on to E. E only has one immediate successor as well. So for that one, our late finish is 8 weeks. It's got a 4-week duration, so we're going to subtract 8 minus 4 equals 4. Now let's go to C. C is our first decision to be made where we've got 2 immediate successors. Okay, we're either going to pick the latest start time of F, that is 10 weeks, or we're going to pick the latest start time for E, which is 4 weeks. Which one do we pick? Well, this is the backward pass. So when we have the option between the largest and the smallest, for our backward pass, you're going to pick the smallest of the 2 LS's. So for C, you will pick the number 4. So for C, you've got your latest finish of 4, your project or activity duration of 2 weeks. So 4 minus 2 equals 2. Now let's go to D. D only has one immediate successor. So you pick the LF of 8. D has a 4-week duration, so 8 minus 4 equals 4. Now let's go to A. A has 2 immediate successors. You've got your LF of 2 for activity C, and you've got your LS in activity C of 2 weeks, and you've got your LS in activity D of 2 weeks. So you need to pick the smaller of the 2 LS's. And for activity A, that would be activity C of 2. So now you're simply going to take 2 minus 2 equals 0. And then let's drop down to B. Your LF of B is going to be 4. 4 minus 3 equals 1. And then when you go to your start, you're going to pick your smallest numbers there of the immediate successors. You pick between A and B, and your smallest LS is 0. So 0 minus 0 equals 0. So now we have done our backward pass. We started at H, we went backwards through the AON network diagram, and we have done our backward pass. Our last step, we're going to calculate the slack. Okay, calculating the slack is pretty quick. We're going to take LF minus EF and LS minus ES. Okay, so let's start with the start. 0 minus 0 equals 0. Now let's go to A. 0 minus 0 equals 0. 2 minus 2 equals 0. Now let's go to B. 1 minus 0 equals 1. 4 minus 3 equals 1. Now let's go to D. 4 minus 3 equals 1. 8 minus 7 equals 1. Now let's go to C. 2 minus 2 equals 0. 4 minus 4 equals 0. Now let's go to E. 4 minus 4 equals 0. 8 minus 8 equals 0. Now we go to G. 8 minus 8 equals 0. 13 minus 13 equals 0. Now we go to F. 10 minus 4 equals 6. 13 minus 7 equals 6. And then we go to h, and 13 minus 13 equals 0, and 15 minus 15 equals 0. Okay, so remember earlier I said if these numbers don't match within an activity, you've got something is going wrong. So for E, you've got a whole bunch of zeros. For F, you have 2 6s. For D, you have 2 1s. For B, you have 2 1s. So these all match. So I know so far, so good. If those don't match, then you either made an error in your forward pass or your backward pass, and you have to start over now. So the slack will help you to determine if you've done something wrong up to this point. Okay, so now what does this tell us? Okay, what does this tell us? We've done our AON network diagram. We've filled the whole thing out. You don't have to put anything in the middle here. You can put an X, you can leave them blank, you can put smiley faces, hearts, whatever you want to do. You can leave those blank, but we are now done with our AON network diagram. So what does it tell us now that we've completed it? Well, now we're going to try and determine the critical path. That's the whole point we do the AON network diagram. So there are different paths to get from the start to the H. It's kind of like a maze. Okay? So our first path, if you follow the arrows, is start A, C, F, H. That path takes us, when you add up all the durations, 2 plus 2 plus 3 plus 2. That gives us a 9-week duration. Our next path is start A, C, E, G, H. So let's add up all those project durations, and that gives us 15 weeks. So 0 plus 2 plus 2 plus 4 plus 5 plus 2 gives you 15 weeks. Next is A, D, G, H. If you add up those durations, that gives you 13 weeks. And then our last path to get us to our completion, which is H, is start B, D, G, and then H. You add up those project durations, gives us 14 weeks. Okay, 14 weeks. So, what does this tell us? Okay, what does this tell us now? Well, we've actually now determined what our critical path is and how long it's going to take us to complete this project, assuming there's no variability in the project duration times. If everything goes according to plan, this project is going to take us 15 weeks. Okay, 15 weeks. Our critical path is the one in red. Remember, the critical path is the one that has the longest duration. Okay, the longest duration. When you add up all those critical activities, from start to A to C to E to G and then to H, that is a 15-week project duration. That is your critical path. It does not mean you don't do activities B, D, and F. You still have to do them. They're just not on the critical path. Now, a couple things to take note of. On the critical path, you can see each activity, the critical activities, have 0 slack. So there's 0 slack for the activities on the critical path. That means they cannot slip. The activities on the critical path cannot slip. The activities not on the critical path, like B, like D, and like F, they have slack, so they can slip a little bit. And the amount they can slip is the slack. So B has a 1-week lead time. It can slip by 1 week because it's not on the critical path. D can slip by 1 week because it's not on the critical path. A cannot slip at all. C cannot slip at all. And E cannot slip at all. And as you work your way through, the activities on the critical path have 0 slack. They're not allowed to slip at all. But activities that are not on the critical path can slip a little bit. All right, so here's what this looks like if we were to put it into a Gantt chart. Okay, earlier we were talking about Gantt charts and what they look like. For Milwaukee Paper, this would be their Gantt chart. You can see that the activities in the critical, in red, are on the critical path. And so those are the critical activities. Let's just say, as an example, that building the high temperature burner, which is supposed to take us 4 weeks, were to slip by 1 week. It's an activity on the critical path. And if it slips by 1 week, then our whole project would get pushed out by 1 week. So instead of this Milwaukee Paper project being completed at that 15th week, okay, that's how long our project duration was. It was going to take us 15 weeks. Now it's going to take us 16 weeks because an activity on the critical path slipped by 1 week. And that's the impact of slippage on the critical path. The activities not on the critical path, like B, D, and F, they had some allowable slippage. Activity F had a slack time of 6 weeks. So you could delay this project a couple weeks, or it could be unintentionally delayed by a couple weeks, and it would not delay the entire project completion time being done in 15 weeks. But something on the critical path, if that slips, like activity E, then your entire project would slip by 1 week. Okay, so we are done creating an activity on node network diagram. We've used the critical path method to determine what the critical path is. For Milwaukee Paper, we calculated out that the critical path would take 15 weeks. And we did that by calculating our forward pass and then our backward pass, calculating the slack time for every activity, and that helped us to determine our critical path. So we are done creating our AON network diagram, and now we'll move on to variability using the PERT method.